Okay, when I say the word oxygen, what's the first thing that pops into your head? Probably breathing, right? But what if I told you that's just scratching the surface? We're gonna see that oxygen is so much more than a gas. It's like the planet's most essential building block, and it's hiding right out in the open.
All right, so let me hit you with a quick question to get us started. If you had to guess the most abundant element in the Earth's crust, I'm talking the actual solid ground, the rocks, the dirt, what would you pick? Come on, take a guess. Silicon? Maybe iron? Those are pretty good bets, right?
Well, you might be surprised to hear this, but the answer is oxygen. Yep, the very same stuff we're breathing is also the main ingredient of the Earth's crust. And that right there, that's our first clue that we've probably been underestimating this element big time. And just look at this chart. This is what's so wild. We're talking about half, 50% of the entire mass of the Earth's crust is made of oxygen. Now, obviously, it's not just floating around as a gas down there. It's locked up, chemically bonded with other stuff, mostly silicon, to form the minerals that make up pretty much every rock you've ever picked up. And it doesn't stop with rocks. Not even close. Think about water. Oxygen makes up almost 90% of its mass. And the air we breathe, a good 20%. And us, plants, animals, we're all packed with it. It's no exaggeration to say we live on, drink, and breathe an oxygen world. Okay, so let's shift gears to the role we all know best, life. But I want us to think bigger than just breathing in and out. Think of it more like a giant planetary breathing system. At its most basic level, the energy you're using right now to listen and think, it all comes from a super slow, super controlled kind of burning happening inside your cells. That process is called oxidation, and oxygen is the key that turns the ignition on our biological engines. And here's where we see this perfect, beautiful balance in action. So you and I and all the animals, we breathe in oxygen and we breathe out carbon dioxide. But plants, they do the complete opposite. They basically take what we throw away, that CO2, and with a little help from the sun, they turn it back into the fresh oxygen we need. It's the ultimate recycling program. And this is literally the chemical recipe for that little miracle. Plants grab 6 molecules of CO2 and 6 molecules of water, zap it with some sunlight, and boom. They create a molecule of glucose, that's their food, basically sugar, and as a byproduct, they release 6 molecules of pure oxygen. This is the engine that keeps our atmosphere topped up day in and day out. But oxygen's power to react isn't just for keeping us alive. Oh no, it's also the cornerstone of our entire civilization. We figured out how to harness that incredible reactivity to literally build the world around us. See, that same gentle reaction that's powering your cells right now, well, it can be unleashed with a lot more force. So why is it so reactive? Well, oxygen atoms are what you might call electron hungry. They are just desperate to grab electrons from other elements. And when you let that happen really fast, you get combustion, you get fire. That's what drives our cars, generates our power, and forges the very steel of our cities. And when we use pure oxygen, not just the stuff in the air, its power just goes through the roof. In steelmaking, they blast pure oxygen into molten iron to burn off all the junk. You see it in high-temp torches that slice through metal like butter. And the space industry? Rockets are basically giant engines that use liquid oxygen as the oxidizer. That's the stuff that makes the fuel burn with incredible force. And of course, on a much gentler note, it's an absolute lifesaver in medicine. Okay, now for a really cool twist in the story. The oxygen we breathe, the O2, isn't the only version of this element out there. It has a kind of alter ego, a different molecular personality that can be both our planet's greatest protector and a really dangerous pollutant. How is this even possible? Well, it's because of a cool chemical concept called an allotrope. So the O2 we breathe is technically called dioxygen. Its cousin is O3, which you probably know as ozone. See? Both are made of nothing but oxygen atoms, but just sticking them together in a different shape, 2 atoms versus 3, creates a totally different substance with completely different rules. And this is where the story gets really wild. Way, way up in the stratosphere, ozone forms this protective shield. It absorbs the sun's most dangerous UV radiation, and I mean, it literally saves all life on Earth. It's a superhero. But take that same molecule and bring it down here to ground level, and it becomes a villain. It's a toxic part of smog that's really bad for our lungs. So same molecule, different address, and it completely flips from hero to villain.
How crazy is that? You know that weird, sharp smell in the air after a lightning storm? Or maybe near some old, sparking electrical equipment? If you've ever smelled that, you have literally smelled ozone being created right in front of you. That big jolt of electricity has enough power to just rip O2 molecules apart, and then some of them get scrambled back together as O3. All right, so to bring this all home, let's circle right back to where we started, with oxygen being packed into the Earth's crust. Because it turns out that's just one example of oxygen's real hidden talent. It's a master architect bonding with all sorts of other elements to create this huge family of compounds we call oxides. And this table here, it's just a tiny peek at what it can build. You combine it with aluminum, you get aluminum oxide. That's the stuff that makes rubies and sapphires so incredibly hard. You mix it with zinc, you get zinc oxide, the key ingredient in sunscreen. Back in the day, they even used calcium oxide to create the super bright limelight in theaters. And yeah, you mix it with iron, and you get iron oxide, which we all know is rust. So when you step back and look at the whole picture, it's just so clear that oxygen is way, way more than just the air we breathe. It's the literal foundation of our planet, it's the fuel for both life and industry, and it's the silent architect behind an incredible range of materials, from gemstones to rust. It really is holding our world together. And that just leaves me with one final thought. We've just peeled back the layers on one of the most simple and common elements there is. And look at the complexity we found. It really makes you wonder, if oxygen has this many secrets, what other amazing stories are hiding in the other things we take for granted every single day?